Okay, now we are going to start with the numerical session. Okay, we are going to start with numerical session of buffer solution. Okay, so first let us see what is the basic question. This is just like a basic question. Okay, and the problem with this topic is it will not be mentioned that it is a buffer question. In most of the question you don't find buffer question. Okay, in the theory class already I told you when there will be chance of buffer. Okay, very good, few started answering also, so that is the advantage of joining in the early. Okay, so zero point 0.1 molar sodium format in this complete question, until unless I don't mention it is a buffer question, you cannot know that it is a buffer question. Okay, nowhere it is mentioned. That is the main problem of this topic. Okay, so here what is the volume of 0.1 molarity sodium formate? What format? Sodium formate. Okay, sodium formate added to 50 ml of 0.05 molarity formic acid. Okay, so formic acid is a weak acid. How you will come to know? You need not to mug up more things. Okay, so what you should do, whenever Ka, pKa they are given or they are asking, that means confirm that it is a weak acid. If pKb is given, that means it is a weak base. If Kb is given, it is a weak base. If Kb is asking, means weak base. If Ka is asking, means weak acid. Likewise, you can understand from the question itself. Okay, so pKa is given and formic acid, that means it is a weak acid. So, and sodium formate. Okay, this is a salt. So salt and weak acid are available. That from that words only you should be able to identify whether it is a buffer or not. Okay, otherwise you will not understand how to you start the question. At least you should be able to understand. Okay, now first sodium formate. Formic acid is HCOOH. Forma means one carbon atom. Okay, in organic I think everybody must be aware. Forma means one carbon, aceta means two carbon. Okay, propa means three carbon, buta means four carbon. Okay, so propane and butane words are normally used in IUPAC also, but pharma word is not used in IUPAC. Okay, so formic acid, that means a carboxylic acid which contains one carbon atom. Formaldehyde, aldehyde with one carbon atom. Okay, likewise pharma word meaning if you know, then you need not to mug up many things. Okay, same way aceta means two carbon atoms. These are the common names and its implications. Okay, so here formic acid and sodium formate. Sodium formate is a salt, HCOONA. Pharma means already I told you one. Okay, so one carbon with salt. So HCOONA is a sodium formate. Understood? So formic acid and sodium formate. These are the two substances. Now it will make a buffer. How you will come to know? Is it understood now? Now once we are confirmed that it is acidic buffer, directly we can substitute here pH is equal to pKa plus log of, I think already you are aware of the theory class of buffer. If not aware, at least attend that theory class, see that video, and you can write the notes so that it should be easy for you to understand the numerical session. Okay, so pH is equal to pKa plus log of salt upon acid. Log of salt upon acid. Okay, now pKa already given as 3.8. pH is already given as 4. Okay, plus log of, here normally we write it as a concentration, but frankly speaking it is not a concentration, it is only moles. Why? Because concentration means mole per liter. So concentration means mole per liter. So but when both of them are available in one single container, they are available in one single container, liter will get cancelled. So you need to write moles only. Okay, and for unit purpose you need not to worry about moles. You can write millimoles also, because milli by milli unitless. This factor is a unitless value. Okay, so first let us see what is the salt upon acid ratio. Okay, so concentration of salt by concentration of acid. Here salt is HCOONA is salt. Okay. Then coming to the acid HCOOH. Now what you will come to know after simplifying this? Log of HCOONA is salt divided by, and this is acid HCOOH. Okay, so this is the acid and salt. Now we want to find out, only this ratio is unknown, only this ratio is unknown, left all are known. Okay, so from this what we can write, I will write it here. The next step I am writing it here. So log of concentration of HCOONA divided by HCOOH is equal to 4 minus 3.8, that is equal to 0.2. Okay, now we want this ratio, so that will be anti-log. What it will be? Anti-log. That means concentration of HCOONA divided by concentration of HCOOH is equal to anti-log of 0.2, anti-log of 0.2. Okay, so once you know that ratio, once you understood that ratio, then it will be easy for you to know the values. I told you just now, it is simply mole ratio only. What ratio? Mole ratio. Okay, now you try, then I will check your answers. Few answers are already available. Okay, then I will confirm whether it is correct or not within few seconds. Okay, now start noting down and start solving. Okay, now I have given you sufficient time here. Concentration means molarity into volume. Number of moles I told you, molarity into volume. Okay, so molarity into volume of formic acid, sodium formate here and formic acid here is equal to anti-log of 0.2. In already question, I think it is given concentration added to 60 ml. What is given, I think in the question already given as 10 molarity. Okay, so this is about the sodium formate, 0.10 sodium formate. Okay, what volume? This is question mark, and molarity is already given 0.05 formic acid. Okay, 0.05 formic acid, and this is 50 ml. Is it understood? So all things we have, only one value is not known. Molarity of the sodium formate is 0.1. Volume we have to find out. Divided by molarity is 0.05. Volume 50. Okay. So by substituting and simplifying, you are getting an answer of, those who got answer of 39.6. Okay. Here volume of sodium formate HCOONA should be 39.6 milliliter. Here we are using millimoles. That's why the answer will be in milliliter. Okay, 39.6 milliliter. 39.6 milliliter. Then you will get this pH, resultant pH. Okay, all of you note down this. It is very basic question, so need not to worry much about it. Okay, next question is 20 ml of 0.2 molarity NaOH. Okay, this is strong base added to 50 ml of 0.2 molarity acetic acid. Okay, then you are getting 70 ml, 20 ml plus 50 ml, that is 70 ml. Okay, added. Then what is the pH? This is first part. Second, whatever the solution it was there, to that how much of NaOH, that to 0.2 molarity only, how much it should be further added to change the pH up to 4.74. Okay, so first you should find out first answer, then you should identify the second answer. Okay, so now I think everybody can start. Now try and give the answers. Okay, now coming to this question. Okay, here we are given with two things. First, let us this type of question for simplification. What we have to do? We have to write the reaction. Okay, so NaOH. NaOH plus CH3COOH. NaOH plus CH3COOH. What it will give? Acid plus base. Simply will give as salt plus water. Okay. So water is not much important. What I have written, NaOH plus CH3COOH gives CH3COO Na plus and H2O. Okay. So here for the reaction, initial reaction, before this you should be knowing molarity into volume is equal to number of moles. Okay, molarity into volume. Molarity into volume, they will give number of moles. If volume is in milliliter, you will get millimoles. Okay, so antilog table they will give, antilog values they will give in the exam. Don't worry about the antilog values. Okay, otherwise, but they will give you sometimes combination. Okay. So initial 20 into 0.2 volume into molarity. Okay, so 20 into 0.2, and here acetic acid is 50 into 0.2. Okay, this is initial, therefore there is no products. Okay, now at final after reaction, this is 20 into 0.2, that means it is equal to how much? 2 to the 4 millimoles, and here it is 10 millimoles. Okay, 10 millimoles, the 4 millimoles. So finally, which is extra here? Acid is extra. How much extra? 6. How much extra it is? 6. Okay. So there won't be any leftover, because finally it is 4 and 10. For this reaction, this is required 1 mole each. Okay. But here during the reaction, it is consumed is 0. Here also consumed is leftover. 4 will react with 4, leftover with the 6. What is this 6? They are millimole. What they are? They are millimole. Okay. This is limiting reagent. This is excess reagent. In terms of the stoichiometry, this is called excess. How much excess? 6. And limiting reagent will decide amount of product. How much it is? 4 millimole. You don't worry about the water. Okay. Now, see, again we are left with acid and salt. What we are left over with? Acid and salt. Okay. So this is weak acid and salt of weak acid with strong base. Okay. Okay, understood. That may be correct. Wait. So 6 millimole and 4 millimole. Okay. Now pH. After assuring that it is a buffer, then only you will substitute. Now we are doing topic-wise questions. That's why immediately you will substitute. But in the examination, what happens is this formula you have to substitute. This formula you have to use. How you will come to know? For that only I am giving you idea. Okay. So topic wise questions very easy. Topic wise questions, they are very easy. Who is this? Don't share all this nonsense. Okay. So pH is equal to, pH is equal to pKa plus log of concentration of salt upon concentration of acid. Concentration of salt upon concentration of acid. Okay. So pKa, here pKa is not given, Ka is given. You have to be very careful. pK log, negative log of 1.8 into 10 to the power of minus 5 plus log of concentration of salt. Actually we should substitute, but we can directly substitute what? Moles. Salt moles are 4 and acid moles are 6. Okay. Now by simplifying, you will get pH. First answer is by simplifying. This will be further I will write up to here already written. Okay. So it will be minus into minus plus. So log 5. This will be log 5 minus log 1.8 plus log 4 minus log 6. Okay. So on simplification, you will get answer. Okay. So first answer already some students have sent, and it is 4.56. First answer is what? 4.56. 5687. The first answer. Okay. First answer on simplifying this, you will get 4.567. Okay. Note down this. Okay, now what we will do? We will do the next question. Our aim is to change the current pH from 4.74 to 4.5687 to 4.74. Okay, so what we will do? We will just add to the same reaction. To the same reaction, we will make it to 4.74. It is just like previous. You forget about this. Okay, so whatever given, it was just a reference. Now our aim is to create a pH of 4.74. I will write again same reaction NaOH plus CH3COOH will give you CH3COONA plus H2O. Okay, so this is the reaction. Now in this one, initial, initial, initial we don't know now. For time being, I am taking it as X. Then after that what I will do, I will change the find the value, then I will subtract from this one. Okay, so X here and here it is 50 into 0.2 and this is 0, this is 0. Okay, now finally once it has to be a buffer, once it has to be a buffer, then what you will do? What you will do, you will just minus this one. Okay, this is already we have calculated, this is 6 millimoles. How much it is? 6 millimole. Previously we have calculated that value only, we are using it here. Okay, so 6 millimoles. Now it is going to be 0. Okay, so 6 minus X. Here how much it is? X. How much it is? X here. Okay, now we will substitute in the same formula. pH is equal to pKa plus log of salt concentration will be X. Okay, divided by acid concentration will be 6 minus X. Okay, so pH. Okay, here pH is already given as 4.74 is equal to pKa. Already we have determined here it as 5 minus log 1.8. 5 minus log 1.8 plus log of x by 6 minus x. Log of x by 6 minus x. Okay. So like this what you will get? You will get moles. Now this is the final moles need to be added. Final moles need to be added to our solution. Final moles need to be added to our solution to get pH. This is not answer. So already we got how many moles? 4 millimoles. Suppose we will get X as a 5. So how much we need to add? 1 millimole you need to add. Okay. So like that, this you have to solve. Okay. So up to here, I think everybody understood now. Okay. Here pH is equal to pKa. This for initially we have calculated from here, then we are substituting here. Here it is X, assuming it as a X and it is 0, 0 and 0, 6 minus X. As it is confirmed that it is a buffer solution, as it is confirmed that it is buffer solution, it will be 6 minus X here and X here. So that salt and acid must be left over. Okay, so until like this you will calculate x value will calculate from this. Then x will be always more than this 4. Suppose 4 more than 4 it is, if it is more than 4 like 6, that means x is equal to 2. That means we have to add 2 millimoles. 2 millimoles. Once you know the millimoles, number of moles is equal to molarity into volume. So you will already molarity is given as how much? 0.2. 0.2. That extra volume you will find out. Okay, is it understood? Now all of you note down this. Okay, we are starting with now multi-concept question. Up to now, we have started only the concept where buffer solution is applicable. Okay, so here right from the beginning, Oswald dilution law, pH scale, and buffer. So all the three concepts are combined in this question. Okay, see here. First, this is a weak acid. Okay, and here also strong acid. So weak acid added with strong acid. Understood? So for that solution, in the first part, what we have to find out degree of dissociation. Okay, degree of dissociation is not applicable for HCl. This you have to calculate for acetic acid only because HCl is a strong acid, so it will undergo complete. So for HCl, how much it is? Just it is 100% degree of dissociation. Okay, and for value 1. And by using this H plus, you have to find out the degree of dissociation. This is basically for acetic acid. Second thing is pH of total solution. Okay. Third thing is pKa. Ka is given, and to this solution, what is added? Sodium hydroxide is added. So acid plus base. Sometimes there is a chance of formation of buffer solution. Check when the buffer will be there, when some of the acid must be left over and base should completely consume and salt must be formed. Three conditions you have to check. Okay, what is the condition? Acid, this weak acid must be left over, or some acid must be left over, base must be completely consumed, and salt must be formed. So finally you should have only two things, salt and acid. Okay, then we will ensure that it is a buffer solution question, and by substituting buffer formula we will solve the question. Is it understood? So this is a homework today. Everybody will solve and submit. Today everybody will solve and submit to me. Okay, up to now whatever the topic we have covered, on those topic only this question is framed. So this is a Ostwald dilution law, this is pH scale, this is buffer solution. Maybe buffer, I am not saying, mostly it will be buffer. You have to ensure before that. Okay,